Working. Hi, Sabine. This is Alex in the room. Can you hear us?
Yes, I can hear you. The quality is not very good, but I can hear you. And my internet is quite wobbly, so I hope I will not fall off.
Okay, I can hear you as well. We have your slides here. I'm asking my technical assistant here, is the idea that she would share her slides or we would share them here? I think the easiest thing, Sabine, is for us to share the slides and you speak over them so you don't have to stream so much. And then just tell us to advance and I will control that, okay?
Yeah, they are recorded though, for the case that I'm falling off.
Would you like us to just play the recording or would you like us to let you speak?
I'm really worried about my internet, so maybe you use the record. If it's, maybe you can test it shortly.
Okay, so if we can play the recording, we will. We'll test that right now. Okay.
Okay.
Thanks. All right. So, how do we find them? So if you can you open up number 2? And then is there a way to? Strange. I wonder. So Sabine, we do, the version we have doesn't have a recording there. Did you? Or maybe there's 2 versions. There were nothing else on her profile.
They were the same version. The one was just with the wrong title, but normally you click on it and it runs through, or you need to push every slide. It was a slide-by-slide recording.
See, I see 3 things in her profile.
The long PowerPoint, the PowerPoint, they're both the same.
They shared to me.
See, that's old. This one. So Jonas and mine, and now this one are all old.
Can you please send it to me?
So this is in the IIASA Connect. Can you get on the IIASA Connect from here?
No, not now.
Okay.
I've got so many.
So,
it could crash. You know?
Yeah. So if you go onto IIASA Connect and find our program, our session, and then click on the names like Sabine, then you get the options of several things that are here.
Okay. Can you send this to an email or something?
The IIASA Connect?
Yeah.
Presentation. Her presentation.
Presentation you want.
Okay.
Basically.
Let me.
Since you know what? You're already here because
I've
got so many.
Yeah, I know. I'll try. Okay. Sabine, you can hear us probably. I'm going to try during Jonas's speech to find yours and then put it on a thumb drive and then we can play it off that. And if that doesn't work, we'll just ask you to talk through. Is that right?
No problem.
All right. Thank you. Okay, everybody, we're going to get started here if we could. Thank you all for making the hike up to this somewhat more distant location. My name is Alex Ruane. I'm going to be co-chairing this session with a virtual co-chair, Roberto Valdivia from Oregon State. And we're going to get started with a short introduction, if we can pull up part 0. But this is session number 83. And let me just verify this is being shared online. Yes, you are screen sharing. And then display settings. Perfect. Yeah. All right. Thank you. Okay, so so we don't see the top. Does anybody know how to make this go away? The top panel. All right. Well, anyway, this is session number 80. We are the only session, I think, listed under agriculture at this conference or at this forum. And our session is called Representative Agricultural Pathways, Cross-Scale and Transdisciplinary Storylines for Agricultural Development and Decision-Making. I'm really excited about the group we have here that is going to be talking about all of these things, different approaches. We have people who are specialized in agronomy, people who are specialized in economics, livestock, global scale, regional scale, local scale. But the bottom line is, how do these things come into a scenario process in a way that will allow us to build scenarios that work not just in the global aggregate, but become scenarios that can be passed all the way into the regional applications that many of us are involved in. So I'm going to give a very short overview because I know time is quite limited with our group today. I'm just going to start by saying the agricultural sector is facing a quadruple challenge. In the coming decades, we have to sustainably increase production to provide healthy food for growing and developing populations, while also adapting to climate change and ongoing climate extremes, while also mitigating emissions from agricultural lands and livestock, and likewise maintaining the financial incentives for agriculture that makes this whole enterprise work. Any one of these challenges is substantial, and put together, it is a very monumental task. So as we're thinking about scenarios, I want to encourage people to think about the trade-offs and the balances and the synergies that might come from these intersecting challenges. So I'm going to do a very brief introduction of this AGMIP acronym you see in the upper left here. AGMIP is the Agricultural Model Intercomparison and Improvement Project. I currently serve as the climate leader and the science coordinator for AGMIP, and there are several AGMIP people in the room. And I'll tell you more about it in a second, but what I wanted to start by is thinking about agricultural models and what we try to do with them. The fundamental thing that an agricultural model needs to do is respond to some kind of change. In many cases, we're thinking about changes being hazards and disasters. So we might ask, how does agricultural systems respond to cold or heat extremes, wet or dry extremes, pests and diseases, storms, air pollution, anything like that. That orange plus symbol in the middle is carrying a lot of weight because there's many more things, as Valerie mentioned today. There's 33 climatic impact drivers, and our models only respond to a fraction of them. So we need to add more and figure that out. But if we have this, it's a little bit blocked at the bottom here, but this allows us to monitor up to present and forecast out into the future in some kind of reactive mode. We can also go backwards for detection and attribution studies to understand the past and what we might have done differently had we known what was coming. That helps us understand. And then, of course, why we're here is because of the long-term trends, changes in climate, also changes in markets, policies, socioeconomic development, and environmental sustainability. This allows us to think more proactively and recognize that we are in a non-stationary set of systems. So AGMIP has taken that general approach and created more than 50 different initiatives that are in general multi-institutional, multi-model approaches. The community is now more than 1,200 climate scientists, agronomists, economists, IT experts, livestock, nutrition, food security. I could keep that list going. But all around the world, people working to try to understand how we can improve these models and then apply them for a variety of different ways. We have people here representing many of these specific initiatives, so I'm not going to go through them all, other than to note this one on the left here, which is this representative agricultural pathways. This is our concept of future development pathways for the agricultural sector itself, which needs to be nested from local up to global levels. Or I shouldn't say nested as much as internally consistent when we make these choices. So you're going to hear a little bit more about that in a moment. So here are these wraps, as we call them. Before I go too far, I have to just take a minute to emphasize that we're really, really proud of one of the co-founders of AGMIP, Cynthia Rosenzweig, who was recently named the 2022 World Food Prize laureate. And as you can see in the commendation here, it's very much oriented around her work in AGMIP and the impact we've had since 2010 already. Of course, Cynthia has been working and creating new fields of research and application for many decades, even before that. So there's going to be a lot of activity leading up to the Borlaug Dialogues in Iowa this October. So just as a stage setter here, we know that farmers are not going to sit idly by as the climate and environment and socioeconomics change around them. What we see when we look at the literature is that people tend to use incremental available options for their first adaptations. And there's a benefit to that. And then there's a slow diminishing and a flattening out where you're not really getting that benefit anymore. That leads people to take on a secondary thing, which is a little bit more involved set of adaptations. Things like not just changing your planting times, but going out and finding different germplasm, different types of seeds, and coming up with different risk management strategies. But again, you eventually face diminishing returns and may have to think about something more transformational. The challenge, of course, is how much time will we spend on these bumpy parts? We want to be going diagonally here, making as much benefit as we can, as quickly as we can. But every time you have those flattening out curves, you're losing out on adaptations that could have been possible. So as we're thinking about the future, how will agricultural adaptation factor into the types of scenarios that we have to build? Can't even read on the bottom. Okay, so in terms of pressures that will shape future land use, I think this group is going to talk more about these, but just to emphasize, there are many things beyond climate change that are going to affect future land use, and therefore these climate scenarios have to link with those other pieces as well. So this is just some frameworks that we've developed within AgMIP to think more about RAPs. And I don't think Roberto is online. If he is, Roberto, please speak up. You can take over at this point. Roberto had a cold earlier today, so his throat was making speaking difficult. But the basic idea is we want to think about RAPs as starting from a global set of drivers like SSPs and RCPs fitting into the frameworks that already exist, but then thinking about the specific drivers on a national level that interact with agriculture, things like policies and the other things you see here. But then, of course, there's also subnational drivers, in many cases in the same columns, but there's a need to kind of understand what those look like. So here's a little bit more of a complex version of that, where we take from global models things like changes in GDP or population or large-scale trade and climate policies. But then as we go further down, we might start asking about regional agricultural productivity, changes in prices and costs in different parts of the world, and the policies that might be developed on a national level. And then as you keep going further down, we might be asking questions about what will a future farm look like? Will it be big farms or small farms? What will the input costs be and other things around soil degradation or water competition, for example. So we've been doing this in AgMIP for a little more than a decade now and working in regions to do what we call regional and integrated assessments. And you're going to hear from some of the authors who have been working in Zimbabwe and in northern India. But the overall approach as we're doing this is to have an inclusive co-development scenario process where we talk to the stakeholders in the regions and develop these representative agricultural pathways with them, test them with our models, and then circle back and say, is that really the agricultural pathway that we want? So there's more that you'll see soon. So in terms of the agenda today, we have oral presentations from Jonas, Sabine, Subhash, Kaveri, Mario, there's lots of forward moving, I guess, Alex, Keith, and Willem. And then there's also a set of poster presentations that you can find virtually if you go online, and they're through the IIASA Connect. So without any further ado, I think we should move forward and invite Jonas up to the stage to get started with the first presentation. And we do have one microphone out in the audience. Kaveri, you can hold on to it now. Kaveri is not going to be running microphone. It's just going to be a communal, pass it around. Whoever has the next question, that the person who asked the last question has to get it over to them. So let's see, Jonas.
Oh, while we're switching, apparently there's confusion with the online access. First off, is texting me that you can't find it. Roberto was posting in the forum that you can't find the link for the live stream.
Okay.
So maybe there is not. What are these 4 participants we see here?
So
there. Oh, can we have these people connect? Can we send out a link real quick that people can join?
So wait, but we do have one person who's connected online, right?
Yep.
So there's a link. So Sabine, if you're online, if you could send an email about how you got online to me, I guess I will try to figure that out and pass it along. And maybe if you have Jonas's address, email him too. And then
there's
Jonas.
a forum.
Yeah.
In the forum, there's people lined up waiting and asking how to get here.
Yeah.
Maybe somebody can post the Google link into that forum.
Okay, so the IIASA Connect forum, we could post.
I guess so. I haven't seen the.
Okay, let me work on that and
Okay,
then thank
cool.
you.
And in the meantime, I get started. So, hi everybody, Jonas Jägermeier. I'm a crop modeler and climate scientist in New York City with Alex at NASA, but working for Columbia. Now I'm being bombarded by people waiting how to see this phenomenal talk. I want to talk about agricultural projections we're doing in AgMIP, the global crop modeling, what we call global gridded crop modeling, as is, based on CMIP 6. A few results, bear with me, some of you have seen that. And then we want to go into the future direction, adaptation, management changes, and what we can do along these lines. All right. Sweet. Works, cool. So this is an animation made by the NASA news team. Neat graphics, just kind of like summarizing what we're seeing. Multi-model ensemble projections, in this case, based on SSP5, RCP 8.5 by the end of the century, multi-crop model, multi-climate model, harmonized projections. That's kind of like the bread and butter what we do in GGCMI, the global gridded crop model under comparison, feeding the models harmonized inputs from management assumptions, climate data, and so forth. And this leads into the agricultural sector in ECMIP that I and Sam Irvin coordinate. So that's just a teaser to look at this in a little bit more detail and unpack what we're seeing. So this ensemble includes 5 CMIP 6 climate models running from 1850 by the end of the century, bias adjusted and downscaled by ECMIP. We're doing different SSP RCP combinations, and we're having 12 gridded crop models doing this so far, still counting. So there's additional teams pointing at you, Andy, running the models just in time. So we're having about 240 simulations per crop. And as I said, the main purpose of this is what CMIP started 15 years ago is now what we're trying in the agricultural domain, harmonize the models using common inputs and assumptions. For example, we developed a new crop calendar that is being disseminated across teams and sectors, all of that. We're doing a yield bias correction, you know, and if I haven't said it, this is a process-based modeling. So we're having mechanistic representations of, for example, CO2 responses and stuff like that. One important note, this is all assuming constant management. So we're deliberately trying to isolate the climate signal. And then the management adaptation is the next step we're following. So real quick, the main result that I want to highlight here is that these responses are more pronounced than previously thought. And by pronounced, I'm saying they're more pessimistic for most crops, but also more optimistic for some others, mostly wheat. And for comparison here, the little gray stack is CMIP 5 based GGCMI results, the Rosenzweig 2014 paper. For maize, global level, RCP 8.5 end of century, plus 1%. Now the new ensemble, new crop models, new climate models, new input data, we're at minus 24%. So that's a huge gap within a few years of research, staggering. So we need to understand where this comes from. And then as said, for the other crops, wheat has slightly more optimistic responses with positive yield changes by the end of the century at global level, obviously regional disparity, regional gradients. And then for soybean and rice, more pessimistic overall, but large uncertainties. So these two crops really need to be interpreted with care. In more regional aspects, the results are more robust. Okay, the second main point I want to bring up is emergence. Time of emergence is a concept that has been used in the climate sciences, not so much in the impact sciences. So we're trying to find the year where an average signal leaves the envelope of historical noise and variability. And that's important to look at the thing from a risk perspective, because a certain amount of change means different things in different environments. So here at global level, we're showing that the new results show that emergence signal substantially earlier than previous crop model simulations. So for maize, within 10 years, and for wheat, emergence of positive change actually within the next couple of years. Now, also on the emergence topic, the impacts we see are more widespread than thought or usually experienced from these crop model simulations. For maize under RCP 8.5, you see the colors depict the year when the signal would occur. And if you accumulate the global cultivated area that would see that kind of signal by the end of the century, we're landing at about 3/4 of global maize cultivated areas that would see that kind of emergence signal, substantially more than in CMIP 5 based simulations. And even under a high mitigation scenario, we see in many major breadbasket regions these kind of emergence occurring. All right, now to the simulation setup. So this should have actually been animated. So bear with me and look at the left part first. So this is what we have done before, right? We're running different climate model scenarios, but we're keeping management constant. What we defer as, sorry about that, the ECMIP group 1 and 2 simulations. So we're holding everything constant to isolate the climate signal. And now in an upcoming effort, what we call group 3 simulations, we want to deliberately change crop model inputs and assumptions according to SSP storylines. And that's why I'm here. That's why we need to talk about what goes into the models and how we can make that consistent across sectors, impact sectors, across communities, how we can integrate that with RAPs, with agri-SSPs, with ECMIP storylines, and make that consistent across scales. One thing we've been working on internally in our community and at PIC, Potsdam Institute for Climate Impact Research, is the growing season representation of crops. So constantly we're planting the same day throughout the future, and we're harvesting whenever the crop is mature. Now in a warmer world, plants will have faster phenological development, shorter phenological stages, including grain filling, therefore an earlier harvest or maturity date. Now, if growing season adaptation would assume that we're developing varieties that would exploit a warmer season, a longer season, and we're coming up with these algorithms that would find the optimal planting and harvest dates based on a decision tree to avoid droughts, to exploit different rainy seasons and in the temperate region, plant earlier, things like that. That is done. That's what we're now using in these setups. We're using the same data across other sectors. And as a snapshot, what the results show, the planting date shift, only planting the crop earlier here, the olive dark gray bar does only a little bit, but adopting a new cultivar or a slow maturing cultivar really brings the huge yield benefits that we're seeing in these results. And that's a pattern across different crops. Now, when we're assuming these cultivars to vastly change, there's limitations based on a study by Florian Sabo et al. Recently showing that these cultivars might not actually be available in our current repertoire. So there are limitations to that. Now, other inputs are more complicated. Let's not say more complicated, but are still in the making. And that includes fertilizer applications, land use, and irrigation. These usually come out of an integrated assessment model framework. Much of it is based on George Hurt's group, LUH2 data. So IAM-based fertilizer applications, land use, and irrigation. And why ECMIP's core idea is to make these assumptions consistent across sectors and communities and scales. There are issues related that I want to quickly raise, and then maybe we have time to discuss it later or over coffee, or that's why I think it's important to talk about. So as said, we need to integrate RAPs, the representative agricultural pathways, and I believe Roberta is just going to talk about it. With other approaches like the Euro Agri SSPs, and then the SSP-related ECMIP storylines in general. These are not necessarily consistent at global scale, and regionally, of course, they are not. We assume management intensification in integrated assessment models that aren't necessarily consistent what we do in our crop models. I have a figure on that just on the next slide. Often these inputs aren't disaggregated enough. So we're doing our own disaggregation of 5 crop types into 15 specific crops, and that's not consistent with other teams. And then just simply putting out absolute numbers will mean very different things for different models. So if I tell one model, put 120 kilograms of fertilizer on your field, the response will be very different in different crop models. So that's homework we have to do in our sector. So this is an example for the different storylines on fertilizer. This is out of the LUH2 data, SSP-specific trajectories for future fertilizer applications. And then on the right-hand side is is the technological change yield estimates out of Magpie. And, this is something we need to align and have a common understanding how we put these things on one page. I think we're running late in time. I just want to briefly highlight a few other developments that are relevant for scenario development and then protocol development. I mentioned a new crop calendar that we have developed, which is average. So that's an average condition. And then we have the algorithm that looks into the future. But it is also really relevant to develop an annual observational crop calendar for all sorts of reasons. And that's what we're doing here, holding together, scraping all observational data that we can get our hands on from all these different institutes, site level experimental data, government data from the USDA. So there's something coming in sometime near future that we can also then derive empirical trends that are not showing on this figure for technical reasons, but you get the idea. And then the last slide actually is we are trying to set up a more sophisticated irrigation protocol where we use ecosystem type model to constrain pure crop models in their water use availability. And we're going to have an Aspen Global Change Institute workshop on that, where we try to improve the representation of irrigation across the model community and family in earth system models, in ecosystem models, and in crop models to try to harness the different capabilities. My summaries, I think we can leave it at that. I think we're running out of time, and very, very happy to discuss these harmonization spins.
All right,
Thanks.
thank you, Jonas. So I have to load the next presentation, so there's time for a quick question. If anybody has a question for Jonas. Andy.
Thanks. So with the wheat results, if I remember rightly, you said the wheat went a little bit more positive. Is that the right way around? Have you looked at why? Because I'm going to show my age here, but between AR4 and AR5, we found the opposite, that wheat went from slightly positive to negative. And I wonder if looking at where that temperature at which wheat yield starts to decline might be a lens through which to look at actually all of those results. I mean, a little bit like the Enley Wang paper, but not, because that was kind of done in a different way. But it'd be really interesting to understand, are those thresholds now believed to be different than was the case before, to kind of unpick the reason for these changes over time in the results? Because otherwise we're just, every cycle we kind of go, things have gone this way, now things have gone that way.
Right.
Be really good to understand.
Yeah,
what's going
no,
on
there's more scrutiny needed for sure. 3 quick points why that is. So there is Alex, how do you call it? The increase and decline, the peak inflection. Alex has a paper on that, interpreting all these different shapes of responses. So wheat clearly has that peak and decline scenario. Mm-hmm. 2 other factors play in here. It's the geographic location. So the high productive wheat areas tend to be located at higher latitudes, where moderate additional warming can actually be beneficial, according to these crop mode simulations. The other thing is CMIP6 comes with a much higher CO2 concentration, and wheat in our models is highly sensitive to CO2, and that's why we see that additional gain. But then other factors might be underrepresented in the models. So the temperature response, heat stress, all these things, not least waterlogging, is not really well represented. So if we had that included, our results might be on the upper end of the spectrum for sure.
All right, thank you. And yeah, I'm sorry that we don't have more time for questions, but our goal here is to seed a bunch of interesting conversations over the course of this week. So while Jonas was speaking, I see that a couple of people have figured out how to get on. I see Christoph is on now and Roberto has figured out to join. I still don't know how you guys managed to join, and Sabine, but thank you for being here. And there are a couple of people in the IIASA Connect forum still trying to figure out what you guys apparently have figured out. So if somebody wants to volunteer to write some instructions, that would be good.
Yeah, thank you, Alex. I just posted on the IIASA Connect how to join.
Okay, thank you, Roberto. All right, so the next talk is prepared by Sabine Homan Kitui from Zimbabwe. And Sabine, I believe I have the version, so I'm going to see if it plays properly. And then
Good afternoon. I would like to illustrate to you the application of future scenarios to support national policy decision-making using the AGMIP representative agricultural pathways. This research was implemented in Ghana, Senegal, and Zimbabwe under the AGMIP CLARE project, funded by IDRC and FCDO. To remind us, there is high urgency for agricultural systems transformation, communities in sub-Saharan Africa facing complex challenges and unknown futures, while governments are strengthening their buy-in to new priorities for research, policy, and development collaboration. Future scenarios are part of techniques and instruments to improve climate change adaptation and mitigation, while using the insights to discuss the deeper obstacles to adaptation and ways forward, supporting in-country progress in policy development by using scenario modeling through stakeholder engagement processes. The aim of this engagement is to analyze the country's agricultural sector performance to implement their national adaptation plans for particular agricultural systems and commodity markets under current and alternative futures, using stakeholder-defined performance indicators. The process is iterative. Researchers engaging with stakeholders and experts in the co-design of development pathways, co-design of adaptation options, and validating research results. This leads to multiple interrelated outcomes, the multi-model framework to link national and regional scenarios, stakeholder engagement that helps to make the results relevant for influencing decisions, capacity development to ensure that stakeholders are able to use the evidence-based information for climate action, and resulting in a series of co-produced research knowledge.
Did we know how to move this thing? Control Alt Shift H. That sounds like wow, amazing. Wow.
Products. We look at representative agricultural pathway as one way to link global to national to subnational levers and drivers to understand how global level drivers would affect national level policies and how the national policies would pan out differently in various subnational farming systems. Important to underline that in a country, policies are differently implemented between the national and subnational level. Hence, we need to look at multiple subnational farming systems and the consistency between national and subnational implementation, given different future scenario assumptions. We can use the national RAP scenarios to visualize the behavior of farming systems under different policy assumptions and climate impacts. For instance, business as usual, seen as a system with weak institutions and policies remaining in a stuck state under a certain level of poverty and food insecurity, as compared to a sustainable development scenario where we have supportive institutions and policies providing incentive frameworks for systems to move forward and upwards, against an unsustainable development scenarios where we assume protectionist institutions and policies that push for short economic gains. However, environmental and society trade-offs bringing down the economic development. To highlight, adaptation decisions are made at the local level, and hence understanding the different levels of consistency and policy implementation between national level and local level impacts and the trade-offs are critically important. We can assume that under a sustainable development, we will have consistency, coordination, political alliance towards sustainable development outcomes, whereas under an unsustainable or business as usual scenario, we often find fragmented and not well integrated efforts in national to local level implementation. We assess the biophysical impacts of these scenarios on important crop and livestock activities for current and future farming under climate change, as well as adaptation scenarios. We can compare the different impacts for crops like maize, sorghum, groundnuts, and we can assess the economic impact depending on the economic importance of these crops and the level of climate change and adaptation impacts on overall farm net returns. Important to see that the impacts are relatively positive and strong on legumes. Legumes, however, being a crop that is often underrepresented in farming system. We can add livestock to the agenda and see that given feed gaps, feed shortages, dry season feed shortages, the impacts of climate change on livestock are strong, and the feed adaptation strategies often not strong enough to compensate for this. We can assess the impacts of these scenarios on vulnerability to climate impact. Here, an example from Navrongo in Ghana. Overall, we see that vulnerability decreases in futures with improved production systems. We see that vulnerability is lower under sustainable development pathway as compared to a business as usual pathway. Across these different pathways, however, vulnerability remains significant and hence the need for improving adaptation strategies. Given these scenarios, we can be in a position to better identify vulnerable regions in a country, the farming systems, the populations within the farming systems that are more vulnerable to climate change, for improved targeting and tailoring of adaptation strategies under future climates and future socioeconomic conditions. We can also assess the impact of these scenarios on poverty and inequality. Here, an example from crop livestock farming systems in Zimbabwe. We are comparing the proportion of households below poverty line, and we see that currently 42% of the households who don't have cattle are almost up to 100% living below poverty line as compared to those who have some or more cattle. Under sustainable development, we see increased farm incomes, improved food security, and greater equity. We have fewer people in all three stratas living below poverty line as compared to business as usual and unsustainable development pathways where those farmers without livestock remain with very low income, and it will be very difficult to move these people out of poverty. The implications are that we need to develop policies and interventions that help to reduce these socioeconomic and biophysical trade-offs in heterogeneous farm populations. Here's feedback on how the Team Ghana sees the scenario-based approach contributing to their national adaptation planning process. This feedback was co-created by researchers with national stakeholders, is relevant for Ghana, and can be applied to other countries as well. Future scenario approaches provide a methodology for evidence-based recommendations to support the national adaptation planning processes. The approach provides reliable quality data on climate projections, along with information on economic feasibility of potential adaptation strategies. Conducting these assessments at the national and subnational level is critical to capture how climate change, policy or technical interventions impact farming systems. And these type of information can then inform farming systems and national decision-making processes. Contributing to capacity building in the use of these tools and methodologies is required for these forward-looking adaptation, analysis, and planning processes to be implemented. Key takeaways for how this type of future scenario-based research can strengthen national policy research and development networks to facilitate and empower key stakeholders in major production system implementing agents to advance climate change adaptation, supporting farming systems transformation. Number one, we are strengthening the national capacity in addressing policy practice gaps by facilitating these type of dialogues to identify capacity needs and use research to support national adaptation plans. Number 2, the knowledge is being generated in partnerships with implementing agencies. Research evidence through local level networks to implement sustainable development pathways. Number 3, widening the cross-scale research policy partnership, like co-designing the research evidence and communication products for the national policies being informed by and addressing the context-specific gaps and needs. Number 4, generating research evidence for scaling, using feedback on research evidence for sustainable development pathways and trade-offs to inform and influence key production systems, the vulnerable systems, the user groups, to national policy networks. And 5, seeing and supporting this as a continuous and long-term process to account for changes in local condition, policy changes, and strengthen local to national networks. Thank you for your attention.
All right. Thank you, Sabine. Now, Sabine has joined from Zimbabwe, but her internet connection is quite weak. So if there's a burning question, we'll take it right now. But I don't see any hands jumping up. You can get in touch with Sabine through IIASA Connect and in other ways as well. Our next speaker is also a recorded presentation, and I guess I just do this one, right? All right, so this will be given by Dr. Subhash, and I see him. Maybe it's just a speaking. All right. This is clocked at just under 10 minutes, so it should be on time.
Good morning, good afternoon, and good evening to all. Myself, Dr. Subhash from India. First of all, I would like to thank the organizers for providing me the opportunity, and also thankful to the committee for granting me 1,750 euro to attend physically in this scenario forum. But due to some administrative reasons, I could not join you. And the topic assigned to me is Sustainable Agricultural Pathways for India under Projected Climate Change Scenario 2050's Need for Corrections Under Pandemic Situation. And these are my colleagues, Dr. Harbir Singh and Dr. Roberto, who are also associated with this work. And this is something about the introduction. As you know, Indian agriculture, which is having record production of various food grains and commercial and horticultural crops for the last several years, and it has exhibiting resilience and ensuring food security during the COVID period also. And the crop productivity in India is much lower than other advanced countries. And due to the following reasons, one is fragmented land holdings, lower farm mechanization, and lower public and private investment in agriculture. And you see the overproduction of crops like rice, wheat, and sugarcane, which led to so many issues like rapid depletion of groundwater table, soil degradation, and massive air pollution, and which will affect the environmental sustainability at one or two places or several places across India. And in addition to this, the climate change and climate variability also affected the small and marginal household, which is around 85% of the total agricultural farms over India. And under AGNIP, ICAR project, that is collaborative project, we have used the AGNIP Regional Integrated Assessment Framework to study the integrated assessment of climate change impact at the farm level. We have integrated the climate model, crop model, and a socioeconomic model using the RCPs as well as the RAPs. At the national level, we have created, and this is the methodology, same methodology we have used to protocol. And as far as the typical farm households in India is concerned, every farm household is having at least one or two livestock component, and also they will grow, they will keep the livestock in their house, and also they will use the milk for their own consumption, and if it is they have more, then they will sell to the market, and also they will use the FIM or Causal to the field. And this is the general structure of the farming system. And under this project, we have a lot of interaction starting from the farmer, the researchers, then officials, and then basically the policy makers at the country level, as well as developmental workers at the regional level. And we have a lot of interaction, a series of interaction from farm level to the country level. And based on this, we have developed the representative agricultural pathways for the national level. And these are the various stakeholder consultation is going on at different level. And based on that, this is the storyline, that is green agricultural pathway line. When we talk about the green agricultural pathway, it is a sustainable pathway. Basically, if the government policies are better management of natural resources, that means they will allocate more funds to the better management of natural resources. And based on that, the farmers may realize long-term gains from the efficient resource source. That means less degradation will be there, and efficient use of on-farm resources, that is low-cost production, and high-tech agriculture, that means sustainable mechanization will be there in future. And based on all this effort, the farm labor gets good employment in rural area, and that means low income disparity will be there. This is the sustainable pathway. And another pathway is gray agricultural pathway. This means because of the high population growth, the agriculture, there may be intensification, agricultural intensification will be there, and then the higher exploitation of natural resources, because already I told there's a less investment in natural resource management and declining land productivity and out migration of laborers. Laborers move from this area to other area, and more allocation for the subsidies and crop insurance will be there. This is unsustainable pathway. And these are the drivers we have developed for the policy, institutional, socio-economic level. That means the variables we have used for sustainable as well as unsustainable pathways. And the arrow mark shows the direction of change and as well as the magnitude of change. And for technology as well as biophysical. And based on that, we have compared the two sites. I'm showing two sites, that is Karnal as well as Meerut site. Both sites are located in different states because as I am telling, this agriculture is a state subject. And when we talk about this, the Meerut and Karnal district, when we talk about there is a temperature change in future, that is 2050s in both the regions, as well as that rainfall pattern also different in both the regions. And when we the impact means when we talk about the climate change impact at the local level, that means rice as well as wheat, there is a reduction of wheat or rice up to 10% decrease in both the sites. And this is the vulnerability based on the rate of analysis and minimum data set model by Roberto. It is found that around 52% of the farms will be vulnerable in Meerut district, while 35% of the farms vulnerable in Karnal district. And that's sustainable green road pathways, that is moderate emission in 2050s. This is the nutshell of the abstract of the farm survey of Meerut as well as Karnal district. There is a lot of difference between both the sites, particularly the socio-economic condition. And when we talk about adaptation, there will be around 57% and 62% of the farms respectively pertaining to Meerut and Karnal would benefit by adopting the adaptation package in response to climate change and the green pathways. And this indicates that there is a lot of difference in the projected net farm income in these two districts because of the socio-economic conditions are different. So it is better. India is a diverse condition. So that's why we are advocating there should be such studies should be conducted in almost all the agroecological zones of the country because entirely different cropping system and everything. And when we talk about the COVID's impact on India's labor market, when we talk about this, the labor market has actually improved after the pandemic. The unemployment rate declined from 4.82% in 2019-20 to 4% in 2021. This is because basically the unorganized sector, they got the labor in the agriculture side. And when we talk about this, there is a shift towards low quality and unpaid jobs under the pandemic situation. And agriculture employment share continued to increase under pandemic situation. And real wages came down across sectors. To be sure, casual workers did see a small increase in their incomes, but they are still under the least paid in the economy. And when we talk about the future, there is a need to develop some dynamic pathways for the future. Dynamic pathways in the sense we need to integrate all the variables under agriculture as well as the aligned sectors. And also there is a linkage between the scales, and also we need to incorporate others also. That means only farm households. We need to integrate other households also into this picture so that we will get a dynamic pathway. That dynamic pathway means suppose in 1 year there is a climate shock or climate variability or some small pandemic, if we can modify automatically the agricultural pathway for the future. This is my suggestion, and thank you for patient listening. And again, thank you for the organizers for providing me the opportunity. Thank you.
All right, we'll clap even though he. All right, so thank you. That is the last of the remote presentations. So getting back to live presentations, our next talk will be given by Kaveri Ashok, who's going to be talking, continuing the conversation about India.
Hello and welcome. I'm Kaveri.
Can we? No, we want to hear you live. Recording, can we say like don't record? Or you could at least, we could also.
You just saved it.
I think if you just click here and press delete, it works. Right?
Can withdraw the slide? Yeah.
Put it on all slides.
All right. It's fine. This is fine. Yeah. Hi, I'm Kaveri. I'm a senior associate with the Center for Study of Science, Technology and Policy in India. We are a think tank based in Bangalore. Thank you to the session organizers and the forum organizers for this opportunity. I would like to present our thoughts and analysis on the agriculture sector in India. It's kind of taking forward what Dr. Subhash had mentioned in the previous session. This is actually a piece of our larger work where we made an system dynamic simulation model for India to understand what are the energy and emissions consequences of achieving different sustainable development goals in the country. So this is just a brief framework of the entire model. So we look at goals in line with the sustainable development goals like food for all, housing for all, healthcare, power, etc. And we like an integrated assessment model, we cover all the economic sectors and what are the emissions and energy consequences. And agriculture is one of the sectors which I will be talking in detail today. So it is essentially a food security goal-seeking module, which is constrained by water and land availability in India. And this is in line with the same inquiry, which is what are the energy and emissions consequences of achieving food for all in the long term. We look at production of food grains to meet a set per capita dietary requirement in the model. And the model basically indicates whether food security is achieved every year, and if not, estimates the shortage and enables the user to explore different strategies to meet the gap. The other key outputs from this model would be energy emissions, and which includes non-energy emissions such as methane from farm, etc. So this is a small snapshot of our interface, which will be available online shortly which will be open to the public for experimentation. So for today's session, what I thought we will focus on is what is our approach to framing these scenarios in the model for the agriculture sector. So for that, I think first let's look at, let's understand what are the policy priority areas for India. And much like Dr. Subhash had nicely explained in the previous session, it's mainly to improve farmer welfare, because about 70% of the country's rural population is directly dependent on agriculture and allied sectors for livelihood. Then, of course, maintaining food security for a growing and developing population, as well as there is also the NDC commitments and climate goals with which we need to control the emissions from the sector as well. We'll go through this in a bit more detail to convey my point. So I'll be using this systems thinking tool called Causal loop diagram. I'll go through this as efficiently as possible. I will not go through each and every variable. So here we have arable land and utilizable water as finite stocks, which are consumed by various sectors. The main point here would be, right now we'll focus on land under food cultivation and the water required. No, it's fine. The land for land and water that gets consumed for food cultivation will be what is being focused right now. So the linkage here shows that the water gets used up to improve yield, which then again which improves food production and therefore impacts food security. For example, I'm just illustrating, so this is the beginning loop. And just to look at the historical data to see how this loop has played out in history, the population of India has been growing at this rate, while the land under food grain cultivation has somewhat stabilized, which means the yield has been improving, which looks to us that as though there is enough water to improve the yield to make the land not go up in the same rate as population. But if some of you might be aware, the water stress in India has been consistently deepening, especially in the food production areas, which is in the northwest and the plains of India. The water situation is pretty dire. So how do we reconcile this, the fact that the land under cultivation is not increased and with the water stress? So the reason is that we've been relying on excessive groundwater pumping, unsustainable pump, going deeper and deeper into the ground to kind of guarantee a yield improvement, whether or not there is locally available sustainable water for extraction. So what this has in effect created is kind of a fallback mechanism for the farmer to improve the yield, no matter whether or not the resource is available locally. So which has again gone back to reinforce this excessive groundwater pumping and create increased depletion of groundwater table in the region. So then next thing that we wanted to look at was whether there are any checks and balances to control this kind of excessive groundwater pumping. So yeah, one thing I missed saying that was the groundwater. This graph is very evidence for the fact that we've been growing the groundwater dependence growing in India over the time from 30% in the 60s. Then during the Green Revolution, it increased, and then it has been at 80-90% reliance by now. So the reason for this is that so then we checked for any checks and balances that can reduce the excessive groundwater pumping in the area, and that would be fuel prices, because water from deeper depths. So then we thought, then we examined whether this will cause a dent in the farmer income and therefore balance out the excessive groundwater pumping. But in reality, we've been seeing that the electricity consumption of agriculture sector has been increasing over time. It did not really cause any checking or balancing for that matter. So the reason why farmer income is more or less immune to this energy costs is because of certain policies that were in place since the Green Revolution. At a time when food self-sufficiency was of utmost priority, government provides electricity for farmers at very cheap or free prices in most states of the country. The additional welfare mechanisms are also there, such as guaranteed minimum price for the staples to safeguard the farmers against any shock, market shock, which is what Dr. Subhash also had mentioned. And as one can see, these policies have ultimately reinforced the groundwater pumping and further GHG emissions. In addition, there is also a cross-sectoral impact that on the power sector. It causes considerable financial burden in the power sector in the form of subsidies that is being given for the electricity consumption of farmers. So just to show how deep-rooted this has been in the Indian ecosystem, some of you may have seen that one of the largest and the long-running protests of the farmers happened in India last year. So this was essentially to protest against farm laws that overhauled policies such as the minimum guarantee price and free electricity. So you can just see how deep-rooted these policies are in the system. So another policy in India that has been gaining traction, mainly to address the financial burden on power sector part, and as well as a big part of our NDC commitments, is to reduce is the solar pumping policy. The solar pumps to replace electric or diesel pumps, which will mitigate the resultant GHG at least, and the subsidy requirement on the power sector. However, once again, as you can see, this will reinforce the excessive groundwater pumping because there is no operational fuel to solar pumps. That functions as good as free electricity. There are several evidence-based studies in literature that says that solar pumps actually further deplete groundwater tables. So this policy has an additional element now in the form of feed-in tariffs for the farmer, which actually increases diversified non-farm sources of income for the farmer, which actually kind of balances out this excessive groundwater pumping loop that we've been forming, this vicious loop that has been forming. But there are other cross-sectoral impacts, and there are some successful case studies in Gujarat, India, where they have developed a scheme called solar power as remunerative crop, so that the farmer is encouraged to sell back the excess electricity rather than use it for deeper pumping. So, but the issue is, some of you, if you are familiar with the energy sector, you know about the California duck curve in a grid where there is more and more renewable and not enough storage capacity. There can be a serious demand supply mismatch, and this can contribute to that. So that is one of the cross-sectoral impact of agriculture. So far our discussions have centered around food cultivation, whereas in India, sugarcane is another major water-intensive crop, which is also a key element in the energy, water, food nexus. So here, on top of the subsidized inputs, farmers also have an additional policy incentive of fair and remunerative pricing policy, which is one step ahead of the guaranteed minimum price, where the prices given to the farmers are in matching with the market prices, which is even more incentive, which acts as more incentive than the grain crops. So this, in conjunction with the fact that sugarcane is the most water intensive and the most irrigated crop of the country, has firmly reinforced this excessive groundwater pumping loop. So from the data, you can see how land has been consistently growing under sugarcane cultivation, irrespective of the demand. We have had a structural surplus of sugar, at least for a decade, because of this policy. So this has caused a lot of international ripples as well. The WTO has reprimanded India for this kind of sugar surplus that India has been putting in the global market. So to deal with this sugar surplus, the government has come up with another policy for ethanol blending. Ethanol blending. So so essentially these policies still remain along with an ethanol blending policy, which actually achieves two of the three policy priorities of the country, where farmer welfare has been, farmer income has been diversified, as well as GHG emissions in the transport sector will be better because of biofuels. But this has ultimately reinforced our excessive groundwater pumping, with which we had started this whole conversation. So this here is the complete loop, where I have also mentioned the other competing demands for land and water, such as urbanization. There's net land demand for urbanization, and the solar and wind mega energy project. As you know, India has upped its climate commitments recently and committed for net zero target. And also there is a growing population requiring drinking water and sanitation requirements. So all of these are competing demands for arable land and water. So as I started with the policy priorities, which is farmer income and to manage GHG emissions. So these are the key policy priorities of the country, and these are the goals that we were looking to meet, which is meeting housing shortage and food security and energy security and so on. So with these, the kind of levers are what we saw, like the free and subsidized electricity policy or ethanol blending policy. These were the kind of policy interventions that were coming with this policy priorities, and that had caused unintended sustainability consequences such as excessive groundwater pumping. So in our sustainability scenario framing, what we did was we changed the focus to the resources themselves and the demand pattern. So we looked at arable land and utilizable water as strictly regulated as hypothetical scenarios to see what are the consequences of these. We looked at the focus change to arable land and utilizable water and food demand, and our the interventions that we came up with fundamentally changed. We looked at what levers like food wastage reduction or dietary shift to less water intensive crops, or water recycling in other sectors, irrigation efficiency, such as, like increased efficiency of conveyance, efficiency of surface water. Can it reduce the dependence on groundwater? And also looking at compact urban forms to reduce land use. So these kind of the kind of policy interventions we looked at got fundamentally changed. So this is a paper we got published last year in Environment Research Letters. So this basically looks at the different scenario possibilities for a regulated water use. If locally available water without excessive groundwater pumping, just looking at the sustainable availability of water, what are the different scenarios? The main learning has been that there is no silver bullet. The combination of scenarios is what resulted in bridging of food grain shortage. Similarly, there's one other, the main thing is that while we did not explicitly have emissions reduction or energy use as a policy focus, the zero gap scenarios we developed with this kind of policy focus was also the least emissions intensive and land intensive. So arguably also most beneficial for farmer incomes in the long term. So in our next phase of work, we are looking at integrating farmer income to the model as well. So in conclusion, in India, at least typically in energy and economic models, the integrated models with agriculture sector, water and land constraints are not considered as a factor. So that may have resulted in the kind of policy interventions that we saw earlier. The Safari framework and model offer a policy testbed to identify the cross-sectoral impacts and the sustainability consequences of different policy choices. Thank you for your attention.
Right. So yeah, we need to keep moving on for times. Thank you. Our next speaker is Mario Herrero, who will be speaking about global livestock and more.
Very much. Hi, everyone. It's a pleasure to be here. My name is Mario Herrero from Cornell University. I'm speaking on behalf of a range of co-authors. We built on a paper that we did for the UN Food Systems Summit on livestock. And what I'd like to tell you a little bit is on what aspects to consider for future scenarios. Well, as we know, there's a lot. Well, livestock is an enormous sector. It uses a tremendous amount of agricultural land, consumes about 70% of water, and also, well, is responsible for around 70% of emissions from the food system. So it's growing also tremendously. There's some misconceptions about livestock. In reality, we have three storylines of per capita demand. It's really, at the moment, it's really all about pork, poultry, growing at an accelerated pace, dairy growing in places, but red meat stagnating everywhere. From a scenarios perspective, this kind of thinking needs to permeate into the future scenarios. Why? Because still some of the global economic scenarios calculate the demand trajectory since 1960s or 1980s, and what you see is an enormous growth of the beef sector, for example. But if you look at the last 20 years, this has actually super flattened out, and it's these kinds of things that really need to be incorporated in the future of for this analysis. And then pork and poultry, you know, if pork and poultry are growing, we're poultrifying the world. And this has a fundamental problem that, well, then we really need to start thinking about, you know, avian flu and things like that, or with pork, African swine fever. All of these things are not even built into some of the narratives. The livestock sector is not well represented in any narrative of the future, be it in the SSPs, be it in any other of the scenarios that have been developed. Well, some of the key points, the next one is the role of livestock in a healthy diet. This was very much at the center of the debate in the first Eat Lancet report. And obviously there's places where we will need to have increases in the consumption of livestock, and in other places a contraction of the sector. Obviously, if you're contracting the sector, you really need to have an idea, and the models need to be able to model, well, then what would happen? What would happen to employment? What would happen to this contraction? What's going to replace it? Otherwise, you know, it's an unfeasible scenario, because something will happen. And if we want to influence policymakers, well, we need to come up with the ideas of what's going to be the thing replacing livestock. Structural change needs to feature heavily. You know, we cannot assume that the livestock production systems will remain the same as we move forward into the future. This happens at the global, subnational scales, and even at the farm level. You know, there's a constant transformation of the production systems. And here, for example, here, what you see, this is data from Steph and Frank here from IIASA. You see this structural livestock component, which is basically, in many cases, relocation of production or total systems shifts to more intensification. And these kinds of things need to be well picked in future scenarios. Narratives will need to include some of these systems changes as we move forward. And the same applies for the crop sector and for all the other sectors that we're talking. The energy guys have done way better in assuming far higher rates of technological change. But we in agriculture have been, you know, I have been super modest in how we consider technological change into the future. Then sustainable intensification. We love sustainable intensification. It's a fantastic topic. It's a triple win. That's not true. There's no triple wins. There's no double wins. It's all full of trade-offs. And in the case of livestock, you know, we know that if we increase productivity, it's fantastic. Yes, but what usually happens is that you end up with monumental amounts of rebound. So you end up doing more of the, using more land, producing actually more livestock at the expense of, you know, having a contraction of the sector, and also ensuring that we reduce animal numbers, which is fundamental for really deploying this. So this is really important to consider also into the future. You know, since I came here to IIASA, probably in 2008, you know, we were thinking of, wow, we really need to get a good grasp of what happens with grasslands in the future. If you look at all the scenarios, have important technological changes and focus on real improvements in the cropland sector, in how we intensify feeds through greater use of crops and everything. But you know, the grassland sectors, we don't have scenarios of what happens if we, you know, increase fertilizer rates, transfers to better pastures, and a range of other things that could play a very significant part in how the livestock sector performs. Obviously, this is fundamental for biodiversity considerations, because it's, well, you know, we cannot go on replacing grasslands for improved pastures at the expense of what? What do we lose? It's really important that we take into consideration this graph from a paper by Jinfeng Chang. Basically, the conclusion was that grasslands at the moment are carbon neutral. When you consider the boreal grasslands, all these areas in the north that are sparsely grazed, that really acts as a super sink of carbon. But if you were only to consider the areas in brown here, then the balances are very positive. They're real contributors to the climate change issue, because the animals with the methane production, etc., will actually produce a lot of greenhouse gases, and the sequestration is not enough. In the managed grasslands, simply sequestration is not enough, and we found sequestration potentials in very, very small pockets of grasslands around the world. So, so if climate changes, and if Jonas all of a sudden tells me that some of those grasslands in the north then become game in terms of a removal of a temperature constraint, that you could start planting wheat and other things, well, we might end up removing some of those carbon sinks. So these kinds of land use considerations will then need to prevail in the subsequent set of scenarios that we develop. Then something that is in vogue is the circular economy. And, for livestock, there's been an explosion of work around this topic. And why? Because, decoupling livestock from land, using circular feeds from actually food waste, or from resources that don't compete with croplands, is something very important. What you see here is the triangles, the pizza slices, represent the protein consumption in the different countries. And the two circles there, the inner circle represents what is the amount of protein that you could produce from low opportunity cost rangelands. And this is about 7 grams of protein per person per day. If you consider that a human needs between 50 and 60 grams per person, you're actually talking about what, 15% coming from low opportunity cost rangelands. Now, if you increase that to include food waste that you could feed to pigs and poultry, this increases to 23 grams of protein per person per capita. This is about 40%. And we could do this fully decoupled from land, because you would be producing all these feed from other sources. So this is a very attractive proposition from a research perspective, because, well, we need to really see how these resources can be used in the future. In Europe, there's already a lot of initiatives on how to use this feed efficiently in the future. But these kinds of technologies, they need to eventually permeate in the next series of regional scenarios that we do, because they are no longer in the realms of our imagination. They're here. Everybody's actually doing them. So we need to be on top of that. Yeah, back to better land use planning, which is central to any aspect of the livestock sector. What you see here is the unaccounted opportunity cost of carbon, of land and carbon. This is simply because, you could do many other things with the land. So, if we treated this as a more open kind of scenario, the green represents what are the current emissions, and the unaccounted potential emissions of what you could do with that land are represented by the bars in the light shaded green. So, really getting livestock to the places where we can actually really raise them with relatively minimum competition then becomes really important. And that calls for probably higher resolution land use models as well, especially when we implement regional scenarios. True cost is my last slide, and true cost is fundamental to start incorporating. This is a paper that we did again for the UN Food System Summit. And basically, you know, if you look at food prices and you look at the current prices of food, we're not accounting for about 2/3 of the costs due to cost of human life, due to unhealthy diets and the environmental costs. How are we going to internalize this without actually leaving no one behind due to potentially increased food prices is something that we really, really need to start engaging in. Why? Because this is very much about the next set of scenarios, also looking at what are going to be the behaviors of the private sector. There have to be narratives associated with that, because, you know, this is not a public problem. This is not a public problem at all. This is about changing behaviors of important big players out there that will have to actually contribute to this transition that we tend to imagine in these kinds of fora where there's absolutely no representative of the private sector involved, nor involved in the future scenarios of what's feasible and so on. And I love this about Volvo, you know, because it's a very classic thing. Look how cool. They just made the patent free of the 3-point seatbelt. It was Volvo who invented it because they thought that you know, it had more value as a life-saving tool. We need to reward this kind of things into the future. Thank you very much.
All right, so our next speaker is Alex Pop, who will be talking about how scenarios come together in the global economics model. Those of you with an eye on the clock will see we're a little bit behind schedule right now through no fault of the next speakers. There's some technical issues, so I encourage people, if they can, hold a little bit into the break so we can get through.
From Alex to Alex, I'll try to speed up. Yep, POPP. Yeah, first of all, I think all of you have the same feeling. It's fantastic to meet in person again. It's like a big classmates party, so really great. Yeah, and thanks for the invitation. Really good session. I'm talking more about the global models, and the idea here is to talk a bit more, to be a bit broader than this kind of classical IPC perspective, and to bring in also this best perspective that has been mentioned also this morning, besides how to spell it, also content-wise. And I would like to start with this prominent figure of the SDGs, the Sustainable Development Goals. And I mean, they're great, but they have to be achieved somehow. And to achieve them, I think that might need a very big and tremendous transformation. And a major role in this transformation has to happen in the land system. Because if you look at the SDGs, I even have a pointer, I think. Does it work? It might. It works. I'm the first pointing person here. I mean, I don't have to point. Just what I want to point out is that almost all of these SDGs are somehow affected by land use systems. And so the land system has really a major role in achieving those SDGs. And this has been picked up by many of publications coming not only, but also in a major role from the global econ team here in ACMEP. Just to mention a few, I mean, there are much more out there, and I think the quality is okay. Keith is sitting here. I mean, climate impacts, there was one starting point for ACMEP, comparing different models, tackling this. We talked about livestock. I mean, livestock is not that well treated yet, I guess, especially in terms of climate impact. It's another issue, Mario. I mean, if you talk to people in Botswana or Zimbabwe, the animals are dying off just simply, just to mention another thing. Talking about mitigation, that's another thing, comparing mitigation and, that also impacts, that's also not coming from ACMEP, but from EMF, also mitigation parts, but also comparing impacts with mitigation. Then also adaptation as a next step, also in a global, in an intercomparison role. And then we are more and smoothly kind of tending to also tackle from the global econ models and the integrated assessment models, the issue of biodiversity and ecosystem services. That's the right direction for tackling sustainable development goals. But we did once, like in 2021, Hélène van Soest was a leading person here, to assess how integrated assessment models. So that's not just land use models, that's broader, but I guess the story also holds true for the global econ models. And what the main message of the study was, it was a big literature review. What we found out there is that the integrated assessment models and the land use modules within these integrated assessment models, they're fairly strong in terms of tackling SDG 13. That means climate action. That's what they were made for, starting with energy systems, adding land use modules and going on. They're also fairly good in terms of some of the resource use, food security, that's our home base here with a global agricultural econ model, so to say, but also starting to tackle also the biodiversity issue. But what we also can see is that the interlinkages within those different domains of the SDGs, so to say, is also very bilateral in the end. That means there's a lot of potential of improvement of kind of getting broader in terms of the coverage of the SDGs. So my main next message here in this slide is that we have to go for sure if we want to tackle the sustainable development target. And that's also kind of formulated in the Paris agenda, so to say. So if we want to go for climate change, that's our obligation. We have to broaden the perspective in terms of not only tackling by climate change, food security, but being much broader. But we also should not forget that if we want to be broad in the perspective, we also have to be good in representing the processes and not only the indicators. And if we want to have the processes, especially for land, we also need to tackle the trade-offs. I mean, Mario, again, you mentioned that if we kind of go, if we have climate change impacts and then the boreal areas, we could use it for cropping, but it would mean a loss of the soil carbon stored in the grasslands. On the other side, what does it mean for biodiversity? That's the next issue. Yeah? So we really need to kind of have a very dynamic perspective of all the things going on there. That's not easy, yeah? But it's just a perspective here. The first attempt that we did here in our institute, led by Björn Circle, was to run the integrated assessment model with many other models together with marine stuff and so on to really cover the full set of the SDGs. It also contains the planetary integrity, biodiversity intactness index, for example, coming similar to the Leclerc paper from the MAGPIE model, but also agricultural water use, and all this is kind of integrated. That means we got broader. But my key message here is really we also need to understand the processes much better, because otherwise the question is, what can we really say in terms of the sustainable development part? That means we need an improved representation of processes and indicators and their interaction. And I would like to stick to, from my perspective, one major process that this global econ models don't really tackle in a good way, and it may even change the sign of the outcomes, I would say. And that's, in the end, the management system. Some models have intensity. We saw the MAGPIE slide in the presentation from Jonas, where we see that yield increases happen, but they are kind of homogeneous within one region. And if we look into the reality, there's much more different variability of systems, and all this and farmers influencing each other in the decision making. And the important part here is if we have this intensity, we can also account for mismanagement. And that's something we don't have in the game for this model, so to say. That means what we need is really a good representation of potential land degradation for crop system, but also for pasture system. And then if we have this accounted for, we can then go for the cascade for integrating the feedbacks also in the mid and into the long term. That means a linking of the ecological impacts, loss of biodiversity, loss of ecosystem services, loss of food production, for example, if the systems erode, and what are in the end the social and the economic impacts of the full thing. I just want to give one example of one postdoc in our group. It was part of his PhD, Miodrag Stefanovic. He did a presentation or did a paper in Science Advances on the impact of high-end climate impacts on agricultural welfare. I don't want to talk in detail about the study. It's just an icon. It's a kind of placeholder for my narrative here. But what we did more or less is kind of the classical thing like you do in GCMII, and all this is kind of we take climate change, feed it into whatever biophysical model. In this case, it was a DTVM, LBGML, and then we used MAGPIE to assess the producer surplus, the consumer surplus, and in the end, the agricultural welfare. But what does it mean if you, for example, have something like biodiversity loss? How does it affect, in the end, the yields? It goes through the full cascade to the human well-being, or as a consequence, land degradation. There's something we don't have in. I mean, we even can't tackle the climate change impact in a good manner. It has been said, I mean, I think it was you, Alex, showing that we have so many different pressures in the system, and it was 5 or so you mentioned, I think. Yeah, but I just want to make the problem bigger. Yeah? And just another thing, if we want to take this process into account, we also have to change the level of spatial resolution, because many of the regulating processes, and this is part of the PhD thesis from Patrick sitting here and presenting after the coffee break in the next session, on how do this kind of big provisioning services like food provision and biomass provision for mitigation or something like this, in a kind of homogenizing the landscape somehow, affecting the regulating process taking place at much finer scales like pollination or soil erosion. And it's a map for 1995, am I right? Or 2015? Okay. Where you can see, for example, from magpie, the pollination sufficiency, and only the like green dots, which are not that many, shape the landscape in a way that their pollination addictive crop production or food production could take place in the most sufficient way. I mean, again, just a placeholder, but this is a level where we have to operate to really say something about the regulating services and the consequences of our agricultural activity. That's it for the moment, and many thanks for the attention.
All right, thanks, Alex, for keeping it short. Keith is up next. Let me see if I can pull up your slide. So Keith Wiebe is coming from IFPRI, the International Food Policy Research Institute. And
thanks, Alex. I'd like to give you a really brief introduction to a new initiative in the Cgiar, and there's a more leisurely version recorded online if you'd like to hear a little bit more. Right. So as you may be aware, the Cgiar is going through a big transformation process. We could spend hours on that, but I'll spare you. What it means is that we're trying to organize and coordinate research better across the different Cgiar centers. You may be aware there are about a dozen of those around the world with different mandates. And they're being reorganized, not the centers, but the research emphases in 3 areas. One on genetic innovation, which is the traditional focus of the CG system dating back to the 1950s and 60s. One on resilient agri-food systems. This is management practices and agronomy and so forth. And one on systems transformation, which is the bigger picture of how food systems interact with natural systems and other economic and social political systems as well. And then linked together as well as at the regional level. All of them working together towards the 5 Cgiar impact areas. And these overlap with, and they're sort of a customization of the SDGs. But for the Cgiar, the 5 principal focus areas are nutrition, poverty, gender, climate, and the environment. So one of the new initiatives in the systems transformation area focuses on foresight. And that is looking specifically years to decades into the future to look at the challenges we'll face on a timescale that requires investment today in things that have a long lag. So research for new varieties or new production systems, or anticipating technologies or population or income changes or changes in dietary preferences. They're going to have big system-wide kind of impacts, but that with sufficient lead time, we can invest, we can make policy choices that will help to influence how those patterns evolve over time. So the initiative's goal is to help provide evidence and capacity to anticipate and to help address those challenges through four broad areas. One is to develop a common shared information base on the types of medium and longer term global and regional scale challenges. We've been hearing about those today. You all address these in your work, so you're very familiar with these. Secondly, working with national partners in selected countries to help them understand, help us understand the challenges they face, the kinds of trade-offs that they're confronting in the policy and investment options they consider under the constraints that they face, and to help them better consider and prioritize and understand different policy and investment strategies. And then third and fourth work package areas are to improve access and to improve capacity to use these sorts of tools. Integrated analysis is critical. I don't need to tell all of you this. And it scales, these are similar to what other speakers have already talked about, spans a scale from subnational, very detailed biophysical type process models, all the way to global markets, and in between, looking in detail at national level, not just food and agriculture system, but in the wider economy, looking across sectors and across types of policy and investment choices, and in fact, dilemmas that many decision makers face. The analysis is important, but without close engagement, it's going to be a distant signal from faraway experts that may or may not have an impact. So we will be working closely with decision makers at multiple scales, some of them at global, but most importantly at the country level in selected countries, and through an iterative process that understands their challenges, helps them understand the tools that we have to offer, helps build capacity, and ultimately to do joint research that explores specific choices that they face. And these range at the global scale from just improving shared awareness of challenges, not that everyone will come to the same conclusion or make the same decision. Everyone has their own constraints and their own objectives, but it helps if they're at least drawing from a common information base. And all of the work that you all do is helping to build that already. What we'd like to do is make that a little more accessible to partners in some of the countries where we work. All the way down to the country level, looking very specifically at particular policy options and evaluating some of the trade-offs that they confront, considering political factors as well as the kinds of things that work a little bit more naturally in some of the models that we use. We don't have time to go into the work packages, but I'll just very briefly mention work package 1 should look very familiar to a lot of you. It's taking RCPs and SSPs and then using those inputs into more detailed models that look more specifically at crops and water and things like that. Ultimately, looking at outcomes in terms of production, prices, dietary change, and things like that at the global and regional scale. Second work package 2, this is led by my colleague James Thurlow at IFPRI. Does similar work at the country level, not just though for the food and ag sector, but the economy-wide modeling. And then as a result, being able to generate insights not only into production and consumption and trade and so forth, but also into poverty and employment, into gender and inclusion. What does it mean for high income and low income consumers and producers, or for men and women, or for rural versus urban, and so forth. Work package in 3, I'll just skip over now. Again, access to tools, transparency, documentation, capacity strengthening with our partners in selected countries. The work packages 1 and 3 will focus at the global scale, but building up from subnational work in some areas. Work packages in 2 and 4 will focus on Eastern Southern Africa in particular, and on South Asia. And within those 2 regions, specific countries, Kenya, Malawi, Rwanda, and Zambia, and Bangladesh and Nepal. Those are areas where we already have well-established relationships with policy research institutes, with ministries of planning and finance and so forth, where we feel like we can begin work fairly quickly in engaging in direct sort of policy analysis and informing the dialogue. Final slide here, opportunities for this community to contribute. Obviously, the work that you all do in terms of global climate, socioeconomic scenarios is very relevant. We want to help, and we want to build from that to help our partners understand what kind of information is available, what sorts of uncertainties are out there, what sort of gaps remain, what it means for them. That includes also representative agriculture, national development, sustainable development pathways. There are different flavors of that that are relevant here. And there are opportunities to provide inputs to that process, to the research and also to the engagement processes, both at the country level and with the funders that support this type of work. So just a quick introduction. I'm happy to talk more with you individually at length, and you can see more of this in the slide as well on the Connect, whatever the forum is called. Yep.
Thank you, Keith. Our last speaker is William Verhagen, who's going to talk about the food security, and my pitch for why, in addition to hearing what I'm sure will be a great talk, if you hang out just a little bit longer, you will have the chance to walk back to the coffee break with the speaker of your choice and ask questions. So here we go.
That's an excellent pitch. And yeah, thanks for that. And thanks for the opportunity to present here today. So my name is Willem Verhagen. I work at the Pardee Center for International Futures at the University of Denver, so where the previous scenarios forum was at. Well, I'll say that I work for the University of Denver from Amsterdam, so kind of a fully post-COVID remote job nowadays. And what I will be talking about is food security and thinking about how we could be achieving food security. There will be some agriculture in that story, but it won't be kind of the main focus. And that's exactly what I hope to be talking more with all of you about today in terms of how can also socioeconomic change inform some of the agricultural pathways and climate change scenarios. So just to set the stage a little bit, and probably not a big surprise for many people in this room, but basically when we currently look at current trends in global undernourishment, what we're seeing is that the world really isn't on track to end hunger, either today or out towards 2040. That's true for some of the analysis that we've been doing. This is an example of work we've done together with USAID, which also tried to look at what is kind of the current business as usual trends in terms of food security and how is COVID-19 affecting that. But it's also more kind of common across quite a broad set of community scenarios. This work, at one hand, focused on prevalence of undernourishment, kind of the most, I think, often used indicator across a lot of global assessments related to SDG 2. But we also started developing some indicators related to child stunting, so kind of a different indicator of food security. So in terms of course, kind of following the notion that we're still kind of not on track to end hunger and achieve SDG 2, there's been increasing academic research, especially at the global level, that looked at, okay, so how can we, what are the solutions to basically improve undernourishment? And part of this work has looked at climate change policies, land-based mitigation. I believe I saw even some of the papers being shown today that show that there are potential risks of climate change to food security, but there's also potential risks of climate change adaptation related to food prices and then the effects that might have on food security into the future. The other kind of part of that work focused more on what if scenarios that really looked at the socioeconomic change. So what if we would be able to indeed reach levels of caloric demand that are sufficient to supply food security, or what if we would be able to meet or to change kind of distribution of food within a country, and how, if that's sufficient to achieve food security, what are the consequences of that for agriculture and emissions? What we are a little bit more interested in, or what we're going to try at least to look at today, is can we actually achieve those socioeconomic trends? And if we don't purely kind of treat the SSPs as largely exogenous, what are kind of, well, target-based or benchmarking opportunities for looking at trends in caloric demand over time, as well as in terms of the coefficient of variation? At the Pardee Center, we work with what is called the International Futures Model, and that's a long-term forecasting tool that operates at the country level for 186 countries. And while we have a representation of agriculture and climate change, it's big caveat, it's much more simplistic than anything that you are all doing. It's non-spatial, it's a single crop, but we do have kind of a much more broader representation of an endogenous change in terms of economic populations, as well as trends in education, governance, access to water and sanitation. So we're really basically trying to model across all the different SDGs and have indicators developed for all of those. Well, it's integrated. It's integrated across countries that interact over time, and it's integrated between those systems in terms of achieving economic and human development over time. If we look at the prevalence of undernourishment, that's where we use kind of a more traditional FAO formulation that, at the one hand, looks at caloric consumption, the coefficient of variation that describes kind of the within-country distribution of caloric consumption, and then a minimum dietary energy requirements. Well, anybody who wants to learn more, you're more than welcome to. You can even run the model. It's completely open source. All documentation is online. Just maybe also of interest, what we mostly work on are like policy reports for USAID, UNDP, and other international organizations, but we are kind of looking and trying to explore more how we can connect with communities like this, but also to expand kind of our academic presence and academic research. So in terms of what have we done here? So we're kind of interested in, okay, well, what if we're not on track to basically end food security? What could we do to potentially improve that and look at like different potential policy strategies and benchmark those in terms of what's possible? So we have a business as usual scenario that describes food security along kind of the business as usual scenario that we have in the International Futures Model. That's, I heard a lot of talk about SSP2, that's the business as usual scenario. If we actually look at kind of economic and population trends in what we try to inform with historic trends, we're much closer to an SSP3 world. So that's maybe something relevant here in terms of kind of what are the kind of economic and population growth dynamics underlying this model. And then we have three kind of different types of interventions: a producing more food, a raising caloric consumption, or an equal food distribution. And all of this comes on top of basically already meeting the agricultural demands. in the scenarios itself. We do benchmarking by, well, basically 3 types of indicators: yield intensities, calories per capita, and coefficient of variation. We do that benchmarking at the world region level. So basically looking at what is the performance on these indicators for different countries within a world region, looking at either the best performer, the medium performer, or somewhere in between. And we do so for different types of SEFs. So data for 2017, but then also in the business as usual scenario, the targets for 2030 and 2040. So what you're seeing here are the results in terms of 151 countries across the world in terms of trajectories of food security over time. And this is prevalence of undernourishment at the global level. So on the line graph, we're basically looking at mean performance across all these, well, 9 scenarios for either producing more food, focusing on raising caloric consumption, or equal food distribution. And basically what we're seeing is that none of these scenarios bring the global prevalence of undernourishment below 3%. Doesn't mean that there isn't any progress. There clearly is, but it isn't like in terms of the mean performance achieving that global target by either 2030 or by 2040. If we look at basically or go into more detail into the individual scenarios, what we're seeing is that there's progress being made by further kind of additionally raising yield intensities. It raises GDP per capita. It lowers somewhat some of the food prices. It also helps a little bit in terms of, well, bigger agricultural sectors in our model also lower inequality, but it's not a transformative change in terms of further kind of raising or lowering undernourishment. And also there isn't much variation between a not so optimistic versus a very optimistic scenario. So even the best performing scenario isn't changing that a whole lot. If we look at the other interventions, the story is a little bit different. Right, we're seeing actually on raising caloric consumption, we're seeing a much stronger impact, but also we're seeing a much stronger variation in which the actual best performing scenarios do bring some of the undernourishment targets below 3%. And the same is true for the more equal food distribution. Now we can look at that at the global level. We can of course also look at that at like different scales. So this is an example for the percentage point change relative to business as usual in terms of undernourishment across several world regions. What might be relevant here and probably not big news, the first 4 regions with the highest prevalence of undernourishment by 2040 are all sub-Saharan Africa. So really when we're talking about kind of the future of food security, at least in many of our trends, we're very much talking about sub-Saharan Africa in itself. Again, what we're basically seeing at the global level is partly also represented at the regional level. There are some positive effects of further increasing yield intensities, but it's especially kind of the socioeconomic interventions on caloric consumption and food distribution that's doing most on undernourishment. What might be interesting as well is that it does depend a little bit per region. So in Africa South and Africa Central, your caloric consumption impacts are much stronger, whereas on Africa West as well as Africa East, the actual food distribution might have a stronger impact on lower in undernourishment. Less kind of, well, moving from the regional level to kind of the country level, what we're seeing here is again, largely a similar story, but in a different way visualized. So about, if we have 151 countries in our sample today, or in 2017, we're talking about 1/3 of the countries having met the SDG 2 target. And even in 2040 in a business as usual scenario, we're close to getting about a half. But that's again, that's positive. It's a big transformation, but it's also I think a little bit worrying that that's still only half of the countries that meet that target. There's again some improvements from further kind of improving yields, but especially again the food distribution, the raising caloric consumption, either bring it to 2/3 of the countries that make this target, or to 3/4 of the countries that make this target by 2040. And this is actually for the most optimistic scenario. So that's kind of the outer edge. So what does this mean? Well, not a big surprise, but future food security, we're really talking about kind of transitions in sub-Saharan Africa to a very large extent. Now, what I want to make very, very, very clear is that none of this is arguing against any agricultural transformation, right? Sustainably raising yields is critical to meet the rising demands into the future. What we're seeing is when we purely focus on a undernourishment indicator, the relative added benefits of even producing more than would be produced in a business as usual scenario to meet the agricultural demand, that's relatively small. There was some positive effects of that on household income. There's some positive effects on that on food prices. So there is a slight overall positive effect on the nourishment, but it's more the socioeconomic transitions that will really determine that. And what I think is also relevant in this is that what it means is that if we look at, or if we really take SDGs as a target, the equal food distribution results in many more countries actually meeting SDG 2 by 2040, but it doesn't produce any extra food relative to business as usual scenario. It's purely a more equal kind of caloric consumption within those countries without the need, for instance, to further raise yields or without the need to further expand land with impacts on climate change as well. So what's next? I'm probably pretty close to the time, yeah. And otherwise just stop me because I can always talk for quite a while. So I am interested in achieving SDG 2. We would argue that really focusing also on the socioeconomic change beyond the SSPs is quite critical. Many of the SDGs will be are very much linked to land, but will really be to a very large extent be determined by socioeconomic change. That's not only true in terms of SDG achievement, it's also partly true in terms of climate impact. So, of course, the impacts of, and I think already in this community, it has been shown quite a bit, the impacts of climate change do differ quite a bit depending on the type of SSP scenario that you would be in. Another handle is thinking about what can we actually do, right? So how could improvements in education, governance, equality, health, and access to water and sanitation, so much more on the socioeconomic side, actually contribute to overall food security. So it's basically a non-agriculture oriented scenario, but really a scenario that would focus a little bit more on socioeconomic change, and also maybe just more practically, if we, for instance, have more healthy diets and less food waste as kind of interventions in the socioeconomic package, would a change in the distribution of food within a country also be one of those interventions that we could play with? That's in terms of the inputs. In terms of the outputs, much of it is really focused on prevalence of undernourishment, which is a really useful population-wide indicator. But there's, of course, many more indicators of food security, including a lot of, child-related indicators of food security, as well as, distribution or coefficient of variation indicators. And those tend to be driven by even less almost agricultural drivers. So, for instance, when we look at child stunting, it relates to levels of maternal education or access, access to water and sanitation, and has, pretty much less to do with kind of the agricultural supply of food. So with that, I'm going to end it, and I'm actually very curious to hear any feedback from all of you, because this is a presentation to an agricultural community, partly saying, well, there might also be a bit more to look at socioeconomic change. So very curious kind of to hear from all of you what you think about that.
All right, thank you, Roman. All right, thank you all for your patience. I'm sorry the coffee break is short, but let's bring this message back to the plenary that there is more to talk about in the sectors and the regions, especially around food. Thank you all for being here.